the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand open arms, this is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Okay, good evening everyone. Let's see if this is working, and if it is, then we can get going. Is the camera wrong, or am I set it in the incorrect place? That doesn't matter. I can hear myself now on YouTube, so I guess that's way better. And yeah, let me just switch YouTube to a lower resolution so it doesn't look out. Hello, good evening officially now. So today's topic is going to be use after free, which is I would say it's actually one of the easiest vulnerability classes when you are thinking about low level. It's easier than buffer overflow, it's easier than you look like you know, your standard print print format bag, and easier than a couple of other things. So I decided to chat about it today. There's also the topic known for the next week's stream. It's going to be, I'm going to try to connect two computers with a sound card, like two sound cards, obviously one for each computer, and you know, to basically try to write a program which communicates using the line input and output of the sound card, which should be quite easy, I think, but I'm going to try to make it somewhat fast. If I do have time, I will also then take a look if I can, you know, route IP through it. But that's next week's topic. And then in 2 weeks, I'm not going to do a live stream because I will be in Geneva in Switzerland on the Insomniac CTF, which is basically the biggest offline event in Europe, I would say, if not the world. It's basically like an open CTF with 8-player teams, and quite a lot of teams usually come. And our team, Dragon Sector, has won that event for the last 4 years, I think. Yeah, 4 years. So we are basically defending the title again. So it should be fun. Yes, today's moderator is KrzaQ. KrzaQ's nickname is right here. So if you have any questions during the live stream, then just let KrzaQ know, and he will magically let me know that there is a question. Now, I'm not going to do the questions probably as they come, and you will not see them here. It's one of the layout changes. But then I will have basically a break, and you will see the questions here. They will show up there, and I'm going to answer them one by one. And the change here is that the question I am currently answering is going to be displayed here, so you will know which question I'm answering, even though I do try to read it every time. So that's that. but I don't think there are any questions yet. By the way, if you are on IRC, you can actually use !Q and then a question. You don't have to catch KrzaQ to actually ask it. Cool. So I guess let's get to it. Okay, so this is my desktop now. What do I have to show you today? I guess KrzaQ's blog, which is the most important thing. Yeah, I don't have my zooming tool turned on. It's pretty weird because like before the Windows update, it actually would launch like automatically, and now it doesn't, so I need to fix it. Yeah, this is KrzaQ's website, so if you're interested in C++ and programming in general, then check it out. Again, thank you KrzaQ for being here. I actually have 2 more things to show you. One thing is I have received this from Ange Albertini. This is, as you can see, a punch card. So initially when people were programming computers, not the first computers, but I guess around 50s, then yeah, they basically had to fill out this form. They had to either punch through or black out proper columns and rows, a couple on every punch card like this, and this was 1 line of code. You basically had to encode 1 line of code in something like this, and yeah, and then you took a box full of these and gave it to the system operator and told them I would like to run it, and they said, okay, I'm going to run it and schedule your thread, your process to be run next week, because next week we have time. And yeah, and then your process run and you basically get a printout of results, and this is way before my time, obviously, but it's an amazing thing. I didn't have a punch card before, so yeah, so thank you, Ange. Now, another thing which arrived, I actually ordered this on eBay. This is an unopened box of double density, I think it's written here, double density, double-sided 512 diskettes. So yeah, floppy disks basically. I'm going to need them for some streams I'm doing in Polish, and then I'm probably going to do them in English as well. So yeah, I'm quite surprised I was able to get on eBay an unopened box of old 5-inch floppies, but yeah, I guess everything is on eBay, really. Cool. Now we can go and do the technical stuff. There are still no questions, which is perfect. So, okay, so what is this use after free I'm talking about? I guess I'm going to kinda mix today. Well, there are a couple of ways to approach use after free, but let's go through the basics. So through the basics is like this. You start by, you need more interaction with an application than you need when you do a stack-based buffer overflow. Usually when you do stack-based buffer overflow, it's quite easy to just have like one function which has the overflow, and you just give it data, it overflows the buffer, and that's about all the interaction you need, unless you need to do, you know, ASLR bypass or whatnot. But when it comes to use after free, you actually need to do some more interaction, because you have to be able to allocate objects on the heap. Yeah, I guess use after free is a heap technique, or well, and free them. So allocate and free them, and you usually need to also be able to write some data or modify the objects and interact with them in some way. So I guess this is a domain of more complex things than simple applications which with simple functions which have buffer overflow. So it goes like this. You basically have a function, let's say, which you have an application which is a remote library application, for example. So you can, for example, add books to the system, right? Now you allocate an object, and this object is a book, and it has some fields like the name of a book, which is probably a pointer to some other memory where the name of a book is, but that doesn't matter, and you, I don't know, have how many pages has the book, right? So you allocate this, and you fill it out with information. You put that this is, for example, Dune, which is a really good book, which I recommend, and it has here you say that it has, I don't know, it had like 600 pages. It's probably a little more than that though. And everything is fine. And then you have some different functionality, like for example, my favorite books, like a list of my favorite books. And in that list, you just keep references to your favorite books, right? So you keep a reference to this object which you allocated. Now, what you do next is you have obviously a function which you can run, and it would, for example, enumerate all the books which are on your favorite list. So it would go through this list. It has only, you know, one element here. This is actually like null terminated, and it would print Dune. Now, you also usually have some other functionality, which, like, for example, this is a library, it has books, but it also, you can also, like, put movies in there or something like that. And let's assume that the, it almost doesn't matter. So, okay, let's not complicate it yet. So, yeah, you just create books and add entries, and you can remove entries as well. So next, what you are going to do, you are going to remove this entry. And you basically deallocate it, right? So this is getting deallocated, yeah, and is now deallocated. Perfect. So what you can do now is you can allocate, for example, a new object about a book, and this comes a little to heap massaging to making sure that the objects are allocated somewhat in the right places where you would want them allocated. So let's assume that this object is allocated somewhere else, and you add a new book, right? And for some reason, the title of a book, which again is a pointer, the text itself is going to be allocated in exactly this space where before we had this entry. Now, therefore, we enter some text here, and we enter a new book name, which is, let's say, AAAA, because the usual reasons, right? And then you put that there, like, I don't know, 123 pages, because why not? And then you go back to your favorite books. Now, please note that there is still this arrow here. It's called the Dangling Pointer, a pointer which is still pointing to something which no longer exists. It has been freed. Therefore, I can still go through my favorite books, and what will happen is this reference, this pointer here, will point to this area of memory. But in this area of memory, I do not have my object, which represents a book anymore. I do have this text. But, well, I don't know that, like the program doesn't know that. Therefore, it will try to grab the first element, the first 8 bytes, 64 bits of it, and treat them as the pointer. And this is my AAA, which is basically a controlled pointer, which allows me to point anywhere in memory, because I control the title, right? I just entered this book, so I control the title, and I can leak some memory thanks to it, because whatever address I put here, it will output it as the title of my favorite book. So if there's a secret password, like administrator's password in the memory, which doesn't happen, but let's assume it is, then if I know its address, I can put it here, and it will get printed out because of this dangling pointer trying to use after freeing this object, use the object which has been freed before. A different approach, if for some reason I could, using this list, also the list of favorite books, also change the title of a book, because there's a typo, I want to change it. That would get even funnier, because I could point with this pointer here to actually a place somewhere in memory which I could overwrite, like for example the stack. And as you know, if I can override the stack, this turns out to basically be, you know, a return-oriented programming scenario. And yeah, that's about it. This is all there is to use after free, basically, is that you have to allocate an object, add it somewhere to a list to create a dangling pointer, the pointer which is not connected to any proper objects later on, and then allocate something else in that place or like around it, which extends over that place, and be able to modify that place, and then dereference it using, again, the dangling pointer which we have here, to interact with it as if it were the old object. And yeah, and that's it. And this usually gives you, yeah, what it gives you, because that's also an interesting question, right? It may give you a couple of things. Usually what it does, it gives you some kind of information leak slash, you can usually leak pointers. For example, let's assume that for some reason in this place where the pointer was, no, that's not a good example. For some reason I could actually control this area but not the area above, so the number of pages could actually leak a pointer, in my case as a number, right? Because if some pointer would be written in this place and then in this place here, and then I would like to output it using the list of my favorite books, it would output some title and then the pointer which would be written here. Obviously everything boils down to how the heap is aligned, how you can place the objects, and this is where you need the interaction to be able to place them as you will. Yeah, so it's either information leak or it goes a little better to a read what where condition. So you basically can read from an area in memory which you specify, or so-called write what where condition, www or www. Write what where condition is where you can write to a place in memory which you point to. And or in some cases where you can actually overwrite a function pointer with some other stuff. For example, let's assume that this number of books for some reason would be in place where some function pointer was allocated before, and there is a dangling pointer which allows me to actually use and call that function, then I could overwrite with the number of pages the function pointer and call any function I would like. So this is basically the best output of use after free, which is rather rare, but it happens. So yeah, so what user after free gives you depends on the exact scenario of what the target you are exploiting. Okay, cool. So let's try to create a small application now, which will demonstrate use after free, and afterwards we can try to exploit it. I guess I do need to create a directory for it first. It's what, 48? Yeah, 48 Livestream. Pretty cool. At least in the English version. Okay, so let's use the book library again idea, because why not? And I'm going to make a basically an application which is a network application, I guess, but I'm probably not going to make it as a network application. I'm just going to make the application interact using standard input and standard output, and I will use some netcat or some other thing to actually, you know, do network redirection. Yeah. So let's go with library.cpp. CPP should be fine for it, and it will make stuff a little easier for us. Okay, so let's code it. I'm probably going to need some list. I'm probably going to need some map or an ordered map. I'm probably going to need string library. I'm probably going to need also some other stuff. I'll include like a cstd.io just for the sake of it. Okay, I'll start with making the setup actually, and so let's do this, and let's do get char just to see if everything is fine, and I'm going to make a make file for this as well. So now let's maybe do this. Click, and here we go. Okay. So the make file will compile it, which will be is this a proper tab? I think it's a proper tab, okay. G++ wall. I'm also going to chat a little how to detect use after freeze, but that's rather easy, I guess. Okay, so this is how to compile it. Now, I guess I'll start with doing it under Linux. Let's see what happens then. Make, okay. So it got compiled. Sorry. Now let's find, I don't know, which netcat do I have here? I have both netcats, perfect. One of the well, you might know that there are two versions of netcats. I'm actually looking for one which allows me to execute a program. It's dangerous, this is exactly the option I want. And it's not as dangerous as they say. So, test, actually, let's go with, yeah, test is fine. Netcat traditional -e library. This is dependent on the auto target, by the way. And -v so we can see what it's actually going on. -l to listen and -p for port. The port is going to be, well, the obvious port, right? This is a hacking live stream after all, so I'm sorry, but we have to go over. Let's maybe make this window a little smaller so you can see it all. And now I'm going to do make test. Okay, n is listening, so I guess if I create another xterm. Okay. We can try to connect to it, so nc-w and then my IP address, well, localhost address, and this. Now, it should actually have outputted this, but it didn't. I'm going to say why it didn't in a second. Yeah, okay, now it's fine. And it should actually close the connection, which it did. Yeah, so if you're wondering why didn't it output anything, even though there is the puts here, right? So we enter and there's the puts. It's because of buffering, basically. Standard output has 3 modes of buffering, as do each file in C. And it's either unbuffered, which means it's always outputted, or it's line buffered, which means that here puts actually emits, you know, the end of line, and everything will be, which is in the buffer, in the output buffer, is going to be flashed to the operating system or through the socket or whatever, but, well, to the operating system to put in the socket after the line of end of line mark is hit. Or there's another one, which is basically if the buffer is fully filled, then and only then it's going to be flashed. Well, not really only then. If you manually flash it, then it's also will happen. Now, by default, when you run an application and the standard output is attached to the console, right? This is a console. Then the mode standard output is in the line buffering output mode. So it sees the end of line, it flashes the buffer. Now, since netcat is actually it's actually redirected the sockets, the network sockets, into standard output and input. That means that, well, the standard output is no longer connected to the terminal, so it switches to the other buffering mode, where it requires a certain amount of data to be put in the buffer before it's actually outputted. And it's quite easy to check as well. We can do this. I have 300. I think it's 1000 actually, the boundary value. So this is 2000 characters now, or almost 3000 characters. So if I do make test and I connect to it, no, it's probably 4000, like 1000 hexadecimal. So it's 13,000 now. Should be pretty obvious what it works now. Yeah, and it works now. It's outputted. So yeah, so that's how it works. It's actually quite useful to sometimes know it, because yeah, otherwise you might run into trouble. There are some applications to change it. Like I could run my library using a certain LD preloading library, which would actually change the buffering mode, or I can change the buffering mode here, which I guess I'm going to do. There's the function called setVbuff or setBuff, or all of them. And yeah, if I do setBuff here, setBuff to standard output, and I set it to the buffer here, this pointer to null, it will tell it that, hey, actually do not buffer it. And I guess I could do the same with standard input, but I'm not going to do it. I'm going to start with this. Cool. And now it should output it, like every time I do a printf or puts or whatever, it should output it. So let's do a clear here, and let's, yeah, and as you can see, it's outputted. So yeah, sorry for the quick digression, but I know some people get confused when the buffering mode changes. Again, if you have any questions at any time, do ping this guy. Like, his nickname is right here, KrzaQ, because that way he can let me know that there is a question. Because I'm not looking at the chat, but I do see the list of questions I have on the other monitor. Cool, so the setup is here. I'm going to close the make file, and I'm probably going to regret closing it in a second. But yeah, let's just do it. Welcome to the library. Okay, now let's do a function which is called menu. What I'm doing is basically like a standard CTF challenge. So yeah, if you played CTFs and you saw a use after 3 being exploited there, then you probably saw a really similar challenge. So the menu will just output the menu, which is like, you know, the options you have, what you can do, the choices. Let's do it like this. 1, add book. Then 2, delete a book. And then 3, add list books, maybe list books. 4, add a book to favorites. Yeah. And 5, let's do list favorites. I'm not going to do delete favorites because that doesn't really matter. Okay, so this is fine. Yeah, let's do it like this. I'm not caring about flashing. Let's do an infinite loop here. I guess I'm going to do a quit here as well. So 0 is going to be quit. I'm probably going to make it quite easy for myself when doing this example, because, you know, it is a live stream and I do hope to have finished this like with like at least some memory leaking exploit during the live stream, so I'm not going to do a full ASLR bypass route. Yeah. Okay, so I'm going to display the menu, and now I'm going to read, well, the choice, right? So I'm basically asking, hey, what do you want to do? And let's just do like if s scanf, because that's easiest. And choice is equals to, I don't have to initialize it actually. If it's equals to, not equal to 1, scanf actually returns how many fields were, format fields, you know, format tags, were properly filled. And I have 1 here, so I expect it to be 1. If it's not, then just like, let's say, wrong option, try again. And no, continue. I actually don't want it to stop. And now I have a choice, so I don't want to create any other bugs, so I want the application to actually work well. So, if choice, so you know what, I'm going to do a switch. I'm going to go with a switch, so let's just do this. And I'm going to use a default here, which will be, yeah, right, well, try again. Okay, that means there's no such option, so there we have it. And now there are only a couple of choices. So there's choice 1, which is add a book. Just going to enumerate them here. 2, 3. I'm going to follow the ordering and the menu. That doesn't really matter. There's break. Oh, break will actually break out of a switch. One of the features I'm missing in C++ is actually breaking from, you know, just typing break to, and that would mean break out of both the switch and the for, or actually be able to label the for, like put some label here like ASDF and write break ASDF, but that's not possible in C or C++. I think it's possible in Java, or I think I saw it in Java, but you can actually label, do breaks with labels, but I can do it here. I'm just going to do a return, I guess, like return 0, because otherwise I would have to create a flag. I don't care about it. Bye. Perfect. And all the other options and cases, I'm going to call some functions. I'm going to use global variables. Sorry for that. Add book, delete book, list books, add favorite, and list favorite. Perfect. Now I guess I have to create all these functions, and I'm kinda starting to require to be able to view at parts of a code, like for example the menu or something. Add book. Yeah, I'm not going to care about any errors, I guess. Like returning an error value or logging any errors. That's fine. That's not that kind of application. Oh, there are some questions. Perfect. I will try to answer them in a second when we do a break. But that will happen after I actually finish implementing this. This shouldn't take too long. So, yeah, this is going to be nasty. I'm going to use global variables again. Don't watch. Well, okay, watch, but don't do this in production code. List, yeah, favorites. So I need to first create like a book. This book class is going to be the description, the object containing the description of a book. And I will have a list of books, and these are going to be two pointers to the books, and these are going to be my favorite books. So favorite books. Okay, and then I'm going to have a map of books. Map. Oh, I actually am going to go for unordered map, so that's fine. Now, do I want to do a book, or do I want to do a book pointer? Does that matter to me? I don't think it matters too much. Yeah, let's just do it like this. This is going to introduce a really nice bug. Books, which is a perfect name. No, it's not, but okay. Private, no, public. I don't care about. This is more C code than C++ code, I realize that, but again, this is just for the sake of an example. This is not production quality code. Do remember that and do not write code like this. And so what are we going to add here? We're going to add... I'm wondering if I should go for a C++ string here, or whether I should go for... Yeah, let's go for a C++ string. This is going to be a little funny, but let's see what happens. Like the name of the book, and what did I else say there? I said that there was going to be like the number of pages, because why not? Pages. Yeah. And I'm actually going to be nice to myself and do it along here. I don't think that will matter in the end anyway. Okay, so now I have this. I can scroll here because I'm going to probably look there. And let's just do a local buffer of one, yeah, the size, and let's put adding book. Did I write a choice here? No, I didn't. Okay, you know, a prompt to basically ask the user for choosing. Which option does the user want? Okay, now have, and what we do here. So usually, one note. Usually, when I don't finish the line with you know, with end of line character, then I would like to do here an f-flash stdout, because otherwise on some operating system, Linux especially, this will not get flashed. and on Windows it might not get flashed either. No, I think on Windows it will, because on Windows it actually the flash is every time after the printf ends, and on Linux is, you know, depending on how the buffering is being done. Anyway, so yeah, but again, I have this here already, the set buffers, so I don't have to do it. But normally I would have to do it if I would like to have the same functionality, so be mindful of that. Printf, what are we printing? Like name. What's the name of the book? And yeah, and we are going to read a name into the buffer. Scanf 123. It's a pretty large size, but that's fine. So if we don't get this, then let's just exit, like protocol, and let's do sorry, and abort the sys exit. No, wait, that's not the wrong language. Exit 1. CSTDV, but that's where it resides. Perfect, and then I'm going to ask for the number of pages. So am I doing this? Am I making this hard for myself? No, it probably should be fine. Yeah, this is where I'm going to probably start looking into man, and you will be wondering what's going on, but no, maybe it should be fine. LLUI, LLD? Yeah, LLI. Now I'm going to go totally for LLI. There's a slight difference between %I and %D in scanf. That's a scanf, obviously. And because I actually accepts also hexadecimal and octal notations, while D only accepts decimal, sorry. If it's not equal to 1, then we basically do the same, which is copy-pasting. It probably shouldn't be copy-pasting this, but doesn't matter. And here is the moment I'm actually creating the... I'm adding it to the books. Sorry, should it be an unordered map? It probably, no, it's probably better to be being a vector or a list. Yeah. Now let's do it on an ordered map, and I'm going to use some index here into it, but that should be fine. Okay, now, yeah. Next index, okay, this is nasty. Which is perfect. Okay, so the next index, and I'm going to actually add add a new book here, and the new book is going to have two things, which is the name, and the name is actually in the buffer, but that's fine, and the pages. Let's see if it works. If it doesn't, then I'm going to fix it. I'm probably going to need to use some emplace here, but maybe this will work. Let's see. Sweet. Now, yeah. Actually this. Yeah. No. Because I want to print here, print. And I'm actually going to change this to 1. Yeah. Add it as, and the index here, now it's an int, so that's fine. Yeah. Okay, so we have adding done, and now deleting. Deleting is going to be pretty similar, but instead of this, I'm going to do int book number, the number of the book which I want to delete, and I do this book number. No, NO is actually book ID. Yeah, book NO means number of books. It's a protocol error, and now I actually check if books.find book ID, if the book ID of that, well, if that book is here, so it's not equal to books, and then I'm actually going to remove it. How do I remove it? I never remember that one. I'm pretty sure it's something like books erase book ID, but I do need to double check it. I'm sorry. CPP reference unordered map. I don't know. remove, erase, erase. Yeah, it is erased. So the question is, can I give it? Yeah, I can give it a type. So this is fine. This is exactly what I wanted. Puts, yeah, removed. Otherwise, then let's just say, yeah, like, why are you trying to remove a book which is already non-existent? So that's a protocol error, which is okay. And list books, this is going to be fairly easy. For, I can do it two ways, but okay, let's do it. Let's do it a nice way. Const auto book from books. Yeah, oops. Now, no, I should like this. Yeah, this is fine. And what I need here is book page, no, ID. I'm not getting an ID here. That's not good. I'd like to have an ID here. But this is not an iterator, is it? Or is it an iterator? Maybe it is the iterator. So let's try. No, it's not unsigned, it's LLI. Okay. Let's see if it's correct. Otherwise, I'm going to change this. Book second name CSTR. Okay, let's see if this works. If it doesn't, well, whatever. And this is unordered. Maybe I should change it to ordered, actually. Yeah, let's change it to ordered. That's going to have a nice effect. Ordered. I think this is the only place where I'm using this. I wanted to do a nice replace, like search and replace, but that doesn't seem to be required. Okay, add a book to favorites. I'm basically going to copy page, perfect. Copy paste this part. Protocol, book ID, perfect. Now find it. If it doesn't exist, then whatever, but we are counting on it to exist at this moment. What happens later on doesn't... Yeah, this is the bug. I'm not going to check when listing favorite books whether that book still exists. So if I don't find it, then whatever. Otherwise, do... and there's also a raise condition here, but I have only one thread, so this is going to be fine. But yeah, like in normal code, if you're going for threads, these should totally have a guard, like a mutex or something. And each of them should have a separate one. Well, that doesn't matter actually. Well, matters later, but okay, this is not a live stream about concurrency. So, favorites push back, and we give it books of book ID. Well, there are already some questions. I'm going to answer them later on. Okay. And now let's just list the favorites. This is going to be like similar as above. So const. No, I actually know what type this is. I'm not going to claim differently. So book. Yeah, that's fine. Of favorites, we do basically the same thing we did here and here. Well, kind of same thing. Because I'm not printing out the numbers, so I'm just going to do this, and this is book from name CSTR because it's, you know, C interface, and pages. Okay, perfect. I have this coded now, the bug is there. Let's see if it compiles, and I do expect quite a lot of actually typos. So yeah, this was expected. Let's do actually clear. This should give me a better overview which bug is the first, because you know in C++ you want to start fixing from the top. Otherwise, yeah, you know, it basically like if you have a bug on top, it basically might snowball into the bottom, causing quite a lot of bugs. So if you start fixing from the bottom, you won't find the bugs there, and if you fixed like $2 or $3 on the top, you'll find that these bugs have disappeared magically. At least that was the case for older compilers. The newer compilers do a pretty good job of that, actually. Expected long end, but it's actually long. Yes, and this type is actually the same thing, which shouldn't matter, but I can do a long. I'm on 64 bits Linux. The long here is the same size as long, but yeah, it's right to complain otherwise. Now, 39 pages long. I knew I had it another place. Favorites was not declared. Favorites. Okay, yeah, so it compiled. Let's see if it works. So I'm going to connect to it. And I want to add a book, and nothing happened. Perfect. Why did nothing happen? So sorry. Where is the switch? Let's look. Add book. So this should happen. And we go to add books. Add book here. And it should say adding book, and it didn't. I'm going to actually add these in a couple of more places. So delete book, then list books. Let's just say, okay. Delete book, listing books, whatever. I know the grammar form and the time isn't correct here, but well, it's correct, but it's not. I'm missing the word. Okay, this is going to bother me. Consistent. Adding favorite. This is just to be sure I don't have any wrong numbers or something. Okay. Yeah, okay, one, okay, no, well, come on. Why? Let's see the choice. Oh, no, this shouldn't be here. That's a stupid bug. Okay. Yeah, now it's fine. So, the name, Dune, and there we go, again. So there's one mistake here which I made, by the way. This shouldn't be like this, it should be like this. Okay. This means, this looks weird, I know, but it means get me at most 1023 characters which are not, this is not, you know, from regular expressions, probably new lines. So this is how you get a line, basically. In, oops. No. Okay. Add book protocol error. Because yeah. It probably should be flashing standard input every time. Maybe I should do just fgets here. So yeah, it's quite funny, but you know what would work? Yeah, I know. I'm going to change one thing. I'm going to actually create a function, and the function is going to just get me integers. So it's going to be bool get int. Am I getting only integers from users? No, that's not true. Okay. Well, whatever. I'm going to do two functions then, and output. Oops. And I'm actually going to grab here the line, and the line is going to be like 64 bytes, and I want it 0 initialized. Then I'm going to do an if scanf, sorry, yeah, scanf, and I want I'm basically going to grab a line. So 63, and then up to until the end of the line, put it in the line. If it's not 1, then actually return false. And here I want to convert my output. I want it to be This function is evil, but okay. No, okay, let's do it in a different way. If scan, we scan the line for one integer and we put it into the output, which is fine. If it's not equal to 1, we return false, otherwise we return true. But I'm not actually going to do it this way. I'm going to do it this way. And which means I have to create output here, which means I have to do this. And this means I'm actually going to do protocol error here and exit. Yeah. Oops. This is much better. Okay, this is fine, this is fine. And here return output. Okay. Now I'm going to do the same thing for a long. I don't think the long is super important here. Li output is a long. I'm not using templates here because this is the tag format changes here, and I would have to specialize it anyway, so that doesn't really make much sense. Okay, so what I change is now I'm actually waiting for I'm making sure that each time you enter a number, you actually have to do the end of a line there as well. And if you don't do it, then that's not good. And I think that this also should eat the end of a line character, but it will not put it in the line here. So this is way better than what I have here. And I'm just going to do get ll. And I don't have to do this anymore. Then here I have to do the same thing, which is get int. And I don't have to do this anymore. And listing adding, this is the same, get int, which I don't have to do again. This is why you don't do your interfaces over standard input. And here it's like choice is equal to get int. Okay. So let's see, scan f, where do I have these? This is fine, this is not fine. I forgot to change it. No. Okay. This is no longer needed. Fine, okay. Or this is fine, but maybe this should fix it now. Let's try. Add a book, protocol error. Come on. But thankfully this means I have only to change it here. Actually do eat the end of the line sign. Add a book, okay, that's better. This is it. I'm going to do one more thing here. Actually, I'm going to disable. Should I disable standard input reading? I probably shouldn't. Standard input should be still like this, buffered, but no, I actually should set the buffering of standard input to set dbuff to be a line buffer. So just to be sure that it is a line buffer, otherwise it gets really funny. So stdin. Yeah. Okay. Maybe this will be a little different. Okay, run it. Add a book. Why doesn't it? After I send the... So there's one more thing. There are two things actually here which are going on. First of all, netcat isn't the greatest tool in the world. And in all honesty, I'm probably going to switch to my exploit toolkit right now. Because I absolutely do not trust netcat when I'm using this kind of interfaces. Netcat is known for having issues. But before I do that, maybe I'm going to do a couple of more things. First of all, I'm going to check this, like, do we actually reach here? Are we reaching this point? So let's try it at, no, it's still, yeah. But why not? Because probably something is buffering stuff on the way here, which means that we are still on this choice. And maybe I should have not added this, but I believe this is the right thing to do. Let's do this again, printf debugging, because why not? Okay, so this is better, but it still writes protocol error here. Which is quite... I'm quite not happy about it. I am line buffering it, so this should be fine. But then we get... No, why doesn't it send it? No, I'm going to put this here. Oh, okay, now I get it. Because I put it only in one place, and it probably should be in both places. Now let's see. One on the book. No. Okay, this is the moment where I actually don't trust Netcat, and I'm going to switch to my exploit framework. So let me just find it. Well, you saw my pawn-based toolkit, I guess, quite a lot of times, so we're not going to be surprised by this rather nasty-looking code. What I do, I give it the port number, then I interact, then I switch to telnet. Perfect. Now let's run it again, and I'm actually going to do... Yeah. Okay, add a book. So it wasn't, I guess, SDF. Yeah. Let's do a funny thing and let's disable the buffering. Let's do two things. Let's do this thing as one. Maybe I should switch to like that, just get line. Yeah, I probably should do that. F gets line 64, and I think the last argument is actually standard. So F gets is a little... I don't remember if it should be. I think it should be 64 actually, but yeah, whatever. GetLine has a nasty habit of actually leaving the new line character at the end of a line, which is why I'm reluctant to use it, but in the end, yeah, let's maybe go over. Okay, compile, run, okay. Yeah, well, way better. Let's see if it works. This doesn't work, so I'm going to replace the name of the book here. Fgets. Okay, stdian. Oh, wait. Yeah, I don't remember. Let's just do it like this. Okay. And yeah, you probably shouldn't do this, what I'm doing here, but I'm lazy. If you're wondering what I'm doing here, is I'm actually removing a new line character in the name of the book. Add a book, done, and something's still wrong. Why is it still wrong? Oh, come on, this should be fine. This is interesting. Okay, let me... So I'm doing this. Let's see if this works, if I comment this out. Oh, I got a segmentation fault, that's even more funny. I shouldn't have this kind of bugs here. I get a name, I ask for it, I read it into the buffer from standard input, and for some reason, I'm not getting all the data. Pretty sure I send it. Seriously. I'm going to just in case check fgets. This isn't the place where I was expected to get stuck, in all honesty. I guess I'm going back to not trusting Netcat. So instead of Netcat, I'm going to switch to a real tool, and which is, you know, Socket. Do I have Socket? I do have Socket, perfect. Socket is a little better. So it's like a netcat on steroids, basically. I never remember how to use it though. So let's look for it. Socket TCP server to exec. Okay, exec. TCP listen, yeah, that sounds about right. And now I do need to open again the makefile, sorry. Here we go. I knew I shouldn't have closed it. So let's do this. Socket from... You basically give it to... Well, two points of the connection. What should be connected to what, which is a really nice way to go about it. So I want to connect this, and I do want to reuse the address, and I want to fork it because why not, and I want to execute the library. Okay, this should be fine. So let's try to run it again, make file test. Yeah, okay, it works. Now let's... Oh, I didn't replace this. How did this happen, by the way? No, that's fine. Whoa. What happened here? That must have been a copy-paste bug. That's really funny. Well, I guess, yeah. I don't know. I'm at a loss for words. So this was actually Frozen. Thank you, Frozen, for spotting it. I was working on the code I thought should be there, but not on the code which was there. Okay. Now, you know what? I'm actually not going to do the fork there. No, let's not do the fork, because that might spawn some processes which I would have to kill, and I don't want to do it. Okay, let's try it again. So, adding a book dune, and I'm stuck again. I'm going to do a couple of more changes. First of all, I'm going to remove this line because I'm not fully certain what this is. Add a book, done. 1, 2, 3, 4. Oh, okay. No, I think everything is fine now. So this is fine. I just was waiting for another thing to appear here, which I actually never implemented. Pages, so yeah, so there were a couple of bugs here because I'm kind of short on prompts in several places. Okay, doing 700 pages. Now list books, it lists doing, but yeah, this. Okay, let's do it again. Add a book, it's called Dune, and it has 700 pages. Now I want to list it. Okay, perfect, now it works. I'm going to add another book, so Lord of the Rings, and it has, I don't know, 3 million pages. List the books, that's fine. Now I'm going to add to favorites, and I want to add, this is another place where I am short on prompts, but there is the ASDF somewhere here still in my code as with the bug message. Okay, so that's fine. Now here which book? Okay, list books is fine because it's not getting any arguments. Wait, where did I put it? No, that's fine. That's fine. Add favorite, which book? List favorites also doesn't take any arguments. So yeah, this is better. And I want to add Lord of the Rings to my favorites. Now I want to list the favorites, and it's here. And now I want to delete a book, and I want to delete which book I want to delete. Well, obviously I want to delete the Lord of the Rings. So I'm going to list the books now, and only Dune is there. and I'm going to show my favorites, and it still shows Lord of the Rings. Now, why does it show it even though I removed it? Because it's still in memory, because when you actually deallocate memory, you don't overwrite it in memory. So this is fine, this is what is expected. Now, if I actually allocate a new book, so let's do just that. I'm going to add a book, and I'm going to call it XYZ, because why not? And it has this many pages. When I list the favorites, what I expect will happen is actually XYZ will show up there. So list favorites, and yeah, and it's XYZ, because I have just reused the place in memory where the dangling pointer points at. So this should be fine for me to exploit it. Sorry it took so long to actually code it. But yeah, but this happens. So let's quit, and let's do some questions now. And after the questions, I'm going to go back and try to exploit it now. And the exploit I'm going for is actually just leaking memory. So I'm going to probably put some... I'm going to try to leak memory at the address 41, 41, 41, 41, blah, 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 you know the drill, right? So let's switch to this. I'm actually going to show the questions, which you should be able to see the questions somewhere here. Here they are. Okay, so in my Lenovo laptop, the USB port failed again after 1 week after motherboard replacement. But I remember I was then and now installing the Intel ME firmware update. Can it be connected or not? Good question. I don't know. It's a question for Lenovo support, actually. It might be connected, but I don't see exactly the reason why it should be connected. But it might be connected, yeah. I don't know. Ask Lenovo support if these are official drivers, but yeah, you have quite a lot of problems with that laptop. I'm not, yeah, I'm not on this. How useful are taint analysis while triaging and writing an exploit? You mean like taint tracking? That's, I would say it's a pretty useful technique. I'm not sure about triaging or writing exploits, maybe when writing exploits, but probably no. I think taint tracking or taint analysis is more useful when looking for vulnerabilities, at least from the way I see it. So usually the taint tracking or taint analysis work is that you try to insert some data into the system which is tainted, and then you see how it progresses through the system, and which areas it touches. For example, if you have some like you can, yeah, one thing which you could do, like for example, you can taint kernel memory, and then from in user mode processes see which tainted kernel memory was actually sent to a user process, and that way you can find information leaks. That's just one of the ideas, but it's a pretty useful technique, but in some cases it's hard to implement, so there isn't a great tooling around it. Yeah, again, for writing an exploit, I'm not sure, because it's might be a pretty invasive technique, so maybe I just don't see an obvious use case. Can you tell us something about game hacking? It's a good question. In all honesty, I don't know that much about game hacking. I guess by game hacking you mean like wall hacks, map hacks, or like editing save games, or like doing trainers or cheats for games. So we actually could do on stream sometime in the future, like adding a trainer to some offline old game. I actually have, yeah, and in my Polish live streams I'm going to do it for a Commodore 64 game, so maybe we can repeat it on an English live stream for a different kind of game. And that's quite easy. Now, when it goes to map hacks, wall hacks, and so on, it's not that complicated either, but yeah, it's a topic for like a whole stream basically. Maybe not showing, but just discussing how they work. Yeah, we'll add it to the list. So that's not a bad idea actually for a stream. Okay. Do you prefer switch style versus the map table of functions? It depends. Switch is faster. In this case, speed doesn't matter, like what I'm writing right now, right? It doesn't matter. Yeah, that depends for what, basically. Usually I would go for the map table of functions, the map of functions. This is basically the preferred way for me to go. But that being said, in case where I know I don't have to extend it, then a switch might be a little better. Just because it's a little more rigid, it's not as flexible as a map table which can be runtime extended. A switch cannot be runtime extended. Then that actually gives you some, for example, detection on the compiler level, whether you have all the functions properly hooked up and so on, which is a gain, I guess. So yeah, it's a different tool for a different job. That's how I see it. Guest writes, my Toshiba is opening DVD accidentally. Do you think it's related to BIOS? It appears after exchanging motherboard service or DVD got broken. Right now I have French BIOS after service repair. Even if I change the language in BIOS to English, it will reset again to French after restart. No, that sounds like you have problems with the motherboard, because if you change the BIOS, it shouldn't revert the settings. So that's pretty weird. Actually, I would ask Toshiba about it. That might be a hardware issue. Okay, how do you identify use after free in production code with code review? Which is a good question. Actually, you find usually this kind of stuff using fuzzing. Like fuzzers are pretty good at finding these kind of bugs. But in a code review, it's a good question. It's basically you have to kind of keep note of all the places where a given object can be linked to, and make sure that, and then basically look when the object is freed, are all these places updated to be sure that they no longer point to that object. But it's easier to discover use after free using runtime techniques. Like for example, one of the tools which I wanted to mention today is Address Sanitizer. You just compile your application with proper flags and then basically run it and play a little with it, or like fuzz it. And if the object is being touched after it's being deallocated, then it's going to throw a big bug report. We can try it on this example in a second. Like, for example, in this case, in this case, when I added the book, right, and it's listing again in the favorites, this would be a huge bug report with Address Sanitizer. It would immediately catch it. So, yeah. Otherwise, it's a little harder using code review because you actually do have to keep track of the important objects which the user can interact with, and be sure that they are updated each time they are removed or added. Okay, next question. Why some security bugs are more dangerous and some less? So it's basically depends on a couple of things. First of all is the severity of the bug, which means what could possibly go wrong in the worst case scenario. And also it's about risk analysis, like how likely is it to be that this bug is going to be exploited. For example, if you have a remote code execution, or no, let's even not go there. You have remote authentication bypass, like you had in MySQL, for example. You know, MySQL had a bug some time ago that if you basically tried enough passwords, it would actually let you in because it only looked at the first byte returned by memcompare. and the first byte could be 0 even if all the other bytes would not be 0 in case of memcompare. So in some cases it would let you in, and that's a really bad bug because first of all it's stable. It is like the application won't crash. The exploit will work 100% times, right? It will always work, and it's remote. And when you get in, you have privileges of a given user. If you get into admin, then you know the root, then that's game over. You can basically even execute code on that machine. So this is a really bad bug. Now there are like bugs which are not so severe. For example, if the bug is you can remotely trick a user to if the user interacts with a website and does something in a specific order, so there's user interaction and quite a lot of it, then you might be able to leak random bytes of memory, and like say 4 bytes. That doesn't sound super, and or the browser crashes in like 50-50% chance, right? So yeah, that's not so bad because it's pretty hard to exploit it, and you get only 4 bytes, and that doesn't give you too much as an attacker, right? 4 bytes, yeah, and random bytes even at that. If you could control which bytes you leak, maybe you could leak a cookie, maybe that would be worth it, but like 4 random bytes out of memory, that just doesn't give you too much. So yeah, it all depends on these factors, like what is the bug class, what can you do with it, what's the final outcome, and how stable is it, can you attack it remotely, does it require user interaction, like all these things factor into how bad a bug is. And not all bugs are super bad. Why don't I use ncurses? This is just example code. I don't think like using ncurses would be required here. If I would like to make fancy UI for, you know, in the console, then maybe I would use ncurses. Or actually, probably not. Probably I would use some of my stuff. Why do you explain it in such complicated code? Have I missed something? I don't think the code is complicated. It might be, you know, my opinion, but yeah, I could explain it, you know, using a program which you don't have any interaction with where you just do the allocation and have a dangling pointer. But I would prefer to do it more like to make it more similar to how you would approach a CTF task and how you would solve the CTF task. Maybe try using \r. No, \r wouldn't be required here. On Windows, either \r is a little more. It's a problem in different places, but it should be fine here. Use readline for getting input. It's fancy. Yeah, readline. Yeah, readline would be really fancy here. I agree. Are the netcat issues moved to socat? So, do netcat and socat have similar issues? It depends on the version of netcat. And no, socat actually works well and doesn't have any issues. Like, I can't even name the exact issues netcat has because I don't know. It's just sometimes something just doesn't work with netcat, and you kind of expect it has to do with line buffering or buffering, and with socat it just works. Guest writes, netcat is called the Swiss knife for TCP. How is it possible you don't trust netcat? Is it time to write your own tool? So no, netcat is the knife of TCP, and socat is the Swiss knife for TCP. So, and as several other protocols as well. But netcat is pretty cool. It's just like a small tool you use for some testing, but if you need something powerful, like socat is the way to go, I would say. And I don't feel any need to write a tool better than socat. Okay, there are a couple of more questions, so let's just go quickly through them and then we get back to exploiting. How to look for use after free, AFL, other techniques. I guess I already talked about it. About USB, most probably it was some broken device cable which broke USB. That's also possible. Like, how was the device called which had a couple of loaded capacitors and basically blew up your motherboard? Maybe something similar. But yeah, if the cable is shortened in some way, then you might actually damage your chipset as well. So that's why I think it might be a hardware issue. And totally chat with Lenovo support. In your code, would you use semaphore or mutex to guard it from race condition? Is there a difference when it's a network-based app or not? So, I guess for single-threaded applications where you are sure there is going to ever only be one thread and probably it won't have, you know, asynchronous calls or anything like that, then yeah, mutex are not really required. It's just not required to synchronize because there is nothing to synchronize, right? And it's not related to network, it's related to how many threads you have and how many threads are interacting with the data. If this would be a server, a TCP server, which creates a thread per client, then I would have to use mutexes, right? I wouldn't use semaphores because you actually rarely use semaphores, it turns out. I know they might tell you on the university otherwise, but you rarely use semaphores, you mostly use mutex. And it's also better if you have like reader and writer mutex, but yeah, but you use mutex basically. So yeah, if you have threads which access the same part of data, you need mutexes, you need atomics, you need maybe some memory barriers depending on what exactly you are doing. Mutexes are pretty cool because they act as memory barriers as well. And curses are that simple. Might be. About Toshiba, the first solution for the problem should be BIOS reflash, update or downgrade. That's Grzegorz actually writes, his comment is, it's pretty good. You can try it. With this example, are we going to cover exploitation with mitigation enabled or disabled? Given that I'm just going for trying to access address 41.41.41.41, I'm not going to care about... I'm not going to walk into the area where mitigations are a problem. So this is totally with mitigations turned on. At least these mitigations. I'm not using any, you know, fancy heap manager, which is, for example, removing all the data once it deletes an object, so or has like a quarantined area. So I'm using the default manager, not a special secure manager, memory manager, of course. But apart from that, ASLR is on and everything else is on. Sometimes in CTF my bin sh payload does not work. I figured it out, sometimes related to term environment variables. Can you explain? That's interesting actually. I would actually have to see one specific example which you have in mind, but I never actually got problems because of term environment variables, so I'm not really sure. I would have to take a look on the specific case what might be wrong there. Can we list processes programs of ring 0 in user mode? Ring 0 doesn't have any processes or programs. Processes and programs are actually a thing of user mode, and in kernel mode you might have several threads and you might have modules loaded, but there's basically only one process, and it's like everything is the one process, and is the kernel. And the kernel might have several threads running doing various things, but there are no processes. So basically no, because it doesn't exist. I don't think in user mode we can list kernel threads, though. You would have to use a kernel debugger for that. USB kill, thank you, Foxtrot. What do you think about realloc? I know some people that try to avoid it. That's an interesting question, actually. I'm not sure why people would like to avoid realloc. The realloc is basically, if you don't know what's realloc is basically allocate the new size of memory and then copy the old memory up to that size into the new allocated buffer and delete the old memory. And that's it. It's basically resize the buffer, but it also can be optimized in a way that it doesn't, that you don't actually don't have to sometimes actually to reallocate the memory. If it's like just a small change, like just trimming it, then realloc is just a knob. It just changes one number and that's about it. I'm not sure why you wouldn't use it unless you're worried about, you know, having the pointer consistency across your program, but similar problems might happen without using realloc. So I think realloc by itself is pretty safe, unless I'm missing something, but yeah. Okay, that's the end of questions, so we can do this and get back to this too. So what we are going to do now is we're going to try to have a sequence of events from this menu that actually brings us to a point where we control the address of a string inside the inside the favorite lists, basically, the list of favorite books. To do that, I'm actually going to open, so I'm going to close this, but I am going to open my Python code. Here we go. Sorry, I'm going to move it here. No, not like this. Okay, or actually I'm going to switch it. So, put my code here. This is exactly what I want to do. Now, the code which I'm going to put here is basically going to call some menu options and give parameters to them. So I'm going to create, I guess, a couple of functions like add book, and it's going to take the book name, so name and pages. And what this is going to do is going to do like this. It's going to send the one option, like select the first option and send an enter. Then it's going to send the name of the book, which is name, and I'm going to actually append this, and it's going to send the pages as a string, so str. This is fine. And I guess it's going to wait for the menu as well. So no, let's just do like this, though I am going to wait for added index, because it returns actually an index. So going to return the index, and to get the index I will have to wait for the added as thingy. So as receive until this appears, and once this appears, I guess I'm going to print it because why not. I'm going to get the index, and to do this I'm going to receive until we get this, and I'm going to change it. No, I'm just going to print it here, so print index, and then I'm going to change it to an integer. Okay. So this is how I'm going to add books, and apart from that I'm going to do receive until. I'm going to receive until I get the choice prompt. So when I get the choice prompt, I'm going to add a book, and the book is going to be called Dune, and it has 600 pages. And then I'm going to again wait for the choice, and I'm going to list the books. That's the second thing I'm going to do. So list books as, and this isn't actually too much work, so yeah. And then list books, and we wait for the choice again. And let's run it. So I'm going to do this, and I'm going to call this. Let's see what happens. It takes one argument, but I totally forgot to give it the argument. Let's do it again. Okay. So yeah, it added successfully the Dune book, which is fine, and it listed the books. So this is cool. Now we have to delete the book, so I'm going to copy paste this. Actually, it's pretty cool to create, you know, like an interface for an API basically in your exploit sometimes, because it gets way easier to it's way easier to code it later on, especially when your logic starts to get really complicated. So delete book is 2, and then send as the string the book ID, which is fine. And then is there anything I need to wait for removed? Yeah, I want to wait for removed. Wait until removed. I don't need anything else here, so that's fine as well. Now list books and list favs, list favorites is going to be really similar. Like just send the option and that's it. And yeah. And one more thing which I'm going to do is add favorite, which is the book ID. And it's going to be the fourth option. So I'm actually going to change the ordering to be the same as it is in the menu. And what else do I send? I just send the book ID as a string with a new line. Is there any adding favorite? Which book added to favorites? This is what I need to wait for. Oops. So print. No, receive until it failed miserably. Okay. Now I can create the, maybe I should actually, well, whatever, never mind. So I'm going to add 3 books. Let's just add 3 books here. Maybe 4 books. It's going to be book A, book B, book C, and book D. Now, if I remember correctly, and I'm going to check it in a second, it's actually that the string C++ string object might have, yeah, let's it uses a certain optimization if I remember correctly. And this optimization is quite important for what I'm about to do. So let's test if it actually works like I think it does. Okay, and what I want to print out is I want to print out the size of it. Okay. I'm pretty sure, yeah, it's 32, perfect. Why is it so large? Because, well, it contains, you know, just the pointer and the length. Why is it so large? But actually it also contains a buffer, if I remember correctly. So let's do a funny thing here of writing out actually the object itself, the string object. And this is not a correct way to do, the correct thing to do, but I don't care, it's going to be fine. Let's put it out, and I'm going to put a string here like A. Let's do this. Call it, okay. And as you can see, inside the object itself, there is the string which I've given it. So it actually has a small buffer of 16 bytes. If the and if the string is actually larger than 15 bytes with a 0 terminator, then it allocates memory inside the RAM, inside the RAM, which is obvious. It allocates memory using the memory manager to actually put the string somewhere else. So if I extend this AAA to something larger, and this is 16 characters, which should be 1 character after the boundary, you will see that it's not inside, it's no longer here, because the buffer it has is too small, so it allocated a different buffer for it, which is quite an interesting thing, this additional allocation, which depends on the size of a string, right? Because we can choose to trigger or not trigger an allocation in memory. So I'm not triggering allocations here on purpose. Neither of this is going to actually trigger the allocation. And now I'm going to do something like this. I'm going to not list. I'm going to add a favorite book. And this is going to be like this. This is going to be 1. No, where did I start counting? Yeah, with 1. So this is going to be 1, 2, 3, 4. Let's maybe... Oh, I guess I can do this. A, B, C, D, because it actually should return the proper things. I'm going to add to favorites. Let's assume I'm going to add C. So C is added to favorites. And now I'm going to remove C. Am I going to remove C? I'm going to remove C and D. So delete books. I'm going to remove C. I'm going to remove D. D is removed second. Now, after I remove it, I'm going to add a new book. Let's call it E as an exploit. And the new book is actually going to, the book object itself is going like this thing. This object is going to be probably put in the same place of this allocation. Because memory managers like to keep a small cache of objects which are of equal size. Now I'm going to do the name. I'm going to try to hit with the name the size of the book object. So the name is actually allocated in this place, like, you know, the next address available. So let's try to do it. What is the size of this? We know this is 32, and we know that this is 8 bytes, so that leaves 40 bytes. Okay. So I need to do this times 40. And yeah, and this is actually like the exploitation book. And given this, it should actually crash my application. Well, not yet. As soon as I print the favorites, it should crash my application. So let's see if it happens. Actually, I'm not going to do this, because it turns into an interactive session, so I'm going to let it do that, and I'm going to use the menu to actually do that. So, okay, running it, and I'm going to list the books. The books are here, which is fine, and now I'm going to list the favorites. I'm going to do this, and let's see what happens. So 5, enter, and oh, it actually did list C. That means that I probably didn't allocate the correct amount or something, like the allocations which I didn't fully align with, didn't have the proper addresses, basically. So, which isn't that great. Let's see again what I can do here then. That means that this actually didn't jump into the right place. Let's, right, because this is too much, because I forgot about the 0 terminator which is added. Yeah, even in C++ strings you actually have 0 terminators. Therefore, I'm going to do 39, maybe this will be fine, because this is now the correct size. Okay, and again, list books and list favorite books, which is 5. No, it's still there. So that means it didn't allocate the proper thing. One thing which I would actually really like to have here is have calls to malloc, which sadly I do not have. Let's try just different things here. I'm going to try 32, and I am going to call list fav here, just for the sake of speed. Okay, it's still C. You know what, I'm going to experiment a little more, and I'm going to add another book like this, but with B, and let's call it like this. Let's see if that way it actually jumps into that location. Okay, it jumps into this location. So 0, which is good. Now let's try with 16 here. Okay, and listing favs, it still didn't hit the proper place. You know what, I'm going to actually do it a little more brute forcey like, because I'm deleting C and D, but I didn't add it to the favorites list. I'm going to add another book to the favorites, maybe. Actually, let's do like this. I'm going to create more books. That's one thing. So let's do it like this for I in range. 20 should be fine. Please add it. Yeah, just like add a book. Plus stri, yeah, with a number. And totally don't print it, I don't care. And then I'm going to add to favorites. I'm going to add at least 10 of these books to favorites. And all of them are going to be dangling pointers. So starting with 2 every second book. And I want to reach at least 18. Yeah, let's do it like this. So yeah, I'm going to add every second book now to the favorites. So add favorite, and I want it to add I, because it should be I plus 1. Yeah, it should be fine. Okay, and then I'm going to remove some books. So I'm going to remove all the favorited books. Yeah, I guess so. So there's one more thing here. I'm actually kinda competing. No, I should. Okay, I shouldn't remove it before. I should remove it now. Okay. I wanted to add removing up there, but no, this is a better idea. Okay, I plus 1. So delete everything. And now add this and list favorites, and let's see what happens. And again, I do not want this to be printed out. So what I'm doing now is I'm massaging the heap, basically. What that means is I'm trying to get the proper layout of a heap, kinda doing it blind. I probably shouldn't be doing it blind, but kinda doing it blind. So, yeah, so given that I'm doing it blind, I don't really see the addresses what's happening on the heap, which would be a little easier for me. Okay, and I'm going to add books, but I'm going to, I guess, add books using... I'm going to add 5 books using different sizes. So I in range up to... yeah, let's just go with 8 as... Oh, let's do it like this. So, and here 39. Let's do it again like this. And let's see what happens. If that doesn't work, I'm going to probably start printing out addresses, just so it's easier. Because what I'm looking for now is I'm looking for this to crash, for this to be not here, but be in one of the places where the object is. And it doesn't like to crash, so that's not great. I probably might want to be a little more sneaky about it, and I might want to create also a couple of books with longer names. Let's try to do it then. Let's just do it like this. I'm going to create all of them with different names. No, I'm going to create some of them with different names. So if I is 0, then otherwise do like, okay, that should be fine. No, 3. Let's do like this. Okay, now we're getting somewhere. This is way better now, because we already have some. Yeah, this is already leaking some memory, and this is what I wanted, but it's not leaking the memory which I wanted it to leak yet. So we're getting somewhere, but we're not yet there. And this is actually leaking memory because of an deallocation and not because really I use after 3, so it's not yet there. Cool. This should be a little funnier. Now, okay, since I removed so many books, I'm actually going to add several more books. Yeah, let's just do this. And the sizes are going to be anything. I'm actually going to reuse this. And I'm using I everywhere, but this is going to be times 16, which should put it in the same. Okay, let's do it like this. This isn't going to work too well. Okay. Okay, so this is the time where I'm actually going to stop for a while and see what I'm doing. And to do that, I'm going to start outputting the addresses of the things I'm allocating. To do that, I guess I could kind of wing it and do here exec is fine, then ltrace. Yeah, ltrace library, let's see what happens. Yeah, that's fine. Okay, that's perfect. But I want to trace only malloc and free, so malloc free, let's try, or maybe memory. It's totally not outputting memory functions, so let's do malloc and free. Okay, let's try it now. Unknown option. Free. Let's try it now. Yeah. Okay. Now we see the mallocs and we see the frees, which is way better. We see basically what's the layout of the heap going to be, and therefore I'm going to decrease the number of objects because I am no longer blind. I can see where the objects are, so I don't need this amount of objects, right? Therefore, I'm going to do it like this. I'm going to remove this, remove this. I'm probably doing this. I also don't need this, and I don't need this. Okay, cool. So, I'm going to create, again, 3 books, let's say. Well, 4 books, I created 4 books, whatever. But I'm going to add to favorites book number 1 and perhaps book number, I cannot all because it doesn't matter really, let's just add all. And then I'm going to remove the book, the second book. And I'm going to add another book. I'm going to, I actually need to remove 2 books. I'm going to remove book number 3 and number 2, in this order. And then I'm going to add a book like this, and then I'm going to list the favorites. So let's see what happens now. Boom, boom. Okay. Now let's see what is actually going on here. I'm going to close this, I guess. Let's do this. So we can correlate whatever we see on the left pane with what we see on the right pane. So this is, oh, it's actually 80. So this explains everything. For some reason, the object is way larger than I expected it to be, and given that it's way larger, this is not enough. So 79, and let's see now. Let us. Yeah, okay, perfect. And segfault. Okay, so that was a simple miscalculation, it would seem. If you're wondering what ltrace is, because I forgot to explain it, ltrace is basically library trace. So strace tool, which you might know is syscall trace, like trace the system calls which the application is doing. And the ltrace is actually hook up to library functions, this function and this function, and output the calls to these functions. And as you can see, this malloc was, for example, called with 80, and this is the pointer, the address in memory which was returned. So what happened here is we allocated 4 books up until this point, right? These are the book objects. And oh, I know why it's 80, because it's actually the map element, and then the map element is actually concatenated with book object, right? So it's the map node object and a book object. This is why it's 80 and not 40. So I actually thought it would allocate the book object somewhere else, but this is fine. Yeah, so it allocated it on these addresses. Just look at the last 3 digits here. Ignore the rest is all the same. Look at these digits, and as you can see, these digits are actually unique. Now this is adding to the favorites, right? Because you add something to the list, and on the list you have, you know, the list node, which probably is a pointer forward, pointer backward, standard list, and also a pointer to the book object. And we don't care about it. This is not important to us. And then we free something. We free F4O, which is this. So this is being freed. This is freed. And then EEO, which is this. These 2 elements are no longer with us, they're freed. So with the next malloc, we can actually allocate them. And the next malloc comes, and this malloc is actually allocating the book object, right? So this is the book. And it allocates EE0, which is what we just freed. Because again, as I told you, memory managers like to keep a cache of recently freed objects, and if a new allocation is of the same size, it's going to be, the area of memory is going to be grabbed from the cache object. It's not every memory manager works like that, but yeah, this one does. And this is for the title. This allocation is for the title, and as you can see, it allocates the address of F4O, and as you can see, it's exactly this address which we deallocated a moment ago. So, yeah, when we next go through the favorites, the list of the favorites, this list which was allocated here, and one of the members is still pointing at this address, expecting there to be a book object there, and it's finds actually the title there, and the title is only letters AAA, so the address is actually OX41, 41, 41, 41, and it's 64 bits, so there is, you know, 4 more 41s here, and this is not a canonical address on 64 bits, therefore it's not a valid address, therefore we get a segmentation fault as expected, so thankfully this works. Now, just to be sure that it works correctly, I'm going to attach a debugger to it. So I'm going to do like this. I no longer need ltrace, so I'm going to comment it out, but I'm going to leave ltrace there. Let's do like this. I'm going to remove this so I have some interaction with it. I'm going to run it. I'm going to run this, and is waiting for the next thing to do, and I now need to attach a debugger actually. So, what's the PID of it? PS-aux. Oh, I guess I can do pgrep library. Okay. So let's just do gdb PID and this thing. And I cannot because I'm not root, so let's do sudo. Okay, and with sudo we're done. I could actually attach to it. So I'm going to let it continue running. So that's C. And now I'm going to list the favorites, and listing the favorites is, I totally don't remember, what is it? Listing, I think it's 5. Yeah, it's 5. So here, and so where is it? Here. 5. Okay. And it's segmented. And it's segmented because it's trying to run string length on something. Let's see what it tries to run it on. So first I'm going to actually set this as assembly flavor Intel because I prefer Intel. show me what instruction did you crash on. So when I rip, and it crashed on like move into the SSE register, something from the pointer rax. Let's see what's in rax. Let's actually see what's in all the registers, so IR. And as you can see, we actually are able to control at least rax register. We control RDI register, we control R8 register, and yeah, and we basically could, using this vulnerability, which we already have, we could leak some memory somewhere. And as you could see before, we actually some time ago, right? I don't know if it's still in the backlog, but let's see. Perhaps it is. Any day now. No, it's not in the backlog. But for a second in the list of favorite books, which was outputted, you could see some non-ASCII characters basically, which means we had an information leak, so we could get a pointer there, and having a pointer, which was probably a heap pointer, we could start leaking information from the heap. And if this would have some functionality like rename the favorite book, we could actually turn it into write what were condition, and that usually leads into code execution probably sooner than later. So yeah, so this is the use after free. As you can see, it's not super complicated. I hope you can see that it's not super complicated. I'm going to upload the code of my exploit and the library and the makefile to GitHub after the live stream, so you can find that it's on GitHub, ginveil, and stream.en here, this repository. Yeah, and there will be a new one here. So you can take a look at the code, experiment with it, try to reproduce it, and basically to get a controlled crash like that with a controlled address which it attempted to access before crashing. I guess that's it. So I'm going to go through the rest of the questions, and then there is a mission actually today. So yeah, there is a mission. So have fun with that. Yeah. Okay, questions. So show. You should be able to see the questions there. There is any way to check if A process reads B process memory, if there is a way to check it. It's actually a good question, and the answer is there are several ways to do it, but it depends on strictly depends on the operating system, and depends on what capabilities do you have to attempt to check it. Because for a process to actually read another process memory, it has to call one of the APIs to be able to do it. On Windows, that's read process memory. I don't think that's the only API, but that's the most frequently used API. So if you have a way to hook that function or like set a breakpoint there, then you will know when it's called on a different process. Now on Linux, you can either use ptrace for reading another process memory, or you can use the sorry, let me switch to the desktop really fast now. Oops, not that. Yeah, I leaked the mission. Oops. So I guess you can look at it, but you will see it in a few moments anyway. Inside the procself, procself directory, there is a file called mem, and this is basically a pseudo file which contains the process memory. And if somebody opens this, then they will have access to the memory of that process. So you can basically monitor what files are opened by the process which you suspect is going to read your process memory. And if this file is opened and this file belongs to your process, you know, the PID here is of your process, because it will be like something and PID of a process here, then you know it's trying to read the memory. Now, if there is something like some other driver which allows you to read the memory of a different process, then it gets a little complicated. But yeah, that shouldn't happen, I guess, unless you have some backdoor. And there's also, you know, some edge case, for example. What if two processes share some memory? How to detect that one process is actually accessing that shared memory? but it's a little harder. This gets rather tricky. You would probably have to have a debugger on that process and set a breakpoint on the memory range. That's a good question, by the way. Some tips for C++ binary reverse engineering. It's a good question. Yeah, C++ binaries are funny because there's a lot of templates everywhere, and as you know, instantiation of a template means generating a set of functions which are, well, a set of required functions for that template, and putting them in the binary. So if you have a template, you are using something which is a template with various types, you will get quite a lot of functions which are used like probably only once in the system. So I guess in C++ is most important to figure out which functions are the standard library and then just work up from that. Just ignore them or try to figure out if they're a list or something else and focus on what is the real body of the program. So that's one thing. The other thing is you can actually try to reverse, like instantiate a list of ints, a list of some objects, a map of some objects, an unordered map of some object, and see how it looks in binary, how the implementation of some functions of a map of a list of a stack from STL actually look in binary. And that way you will actually know when you see it next time how it looks like and what to look for and what to ignore. Apart from that, no, it's like a pretty much a standard reverse engineering process, I would say. The compiler helps, even if it's, you know, IDAS, the compiler still helps. That's just general tips. It's great if you have like symbols. Please explain the sentence. Heap overflow and dangling pointer is used after 3 bugs are two different things. Yeah, they are two different things, because a heap overflow isn't the correct term, right? It's heap-based buffer overflow. So it means you have a buffer which is located on the heap, and you overflow it. You write after the buffer. I actually have the camera switch, so you overflow it. I mean, you overflow it, right? And you start overwriting the heap structures. So you don't really need a dangling pointer or anything. You just overwrite the heap structures and then start interacting with the heap in a way which uses the corrupted structures of the heap to, for example, get write what were condition, and from that again getting code execution while having write what were condition and some pointers is usually trivial. Maybe not trivial, but it's easy. So, or you can overwrite some other object which is later on the heap, which is, not related to heap structures, but it was just allocated and placed on the heap, and you can overwrite it too. So that's heap overflow. Now, use after 3 is, as I explained today, it's something different. You are not overflowing anything. You are keeping into the boundary of a given object. It's just that there is some different part of a system which thinks that, oh, in this place on memory, there is a different object, or was a different object, and it still thinks it's a different object there, and it tries to use it as this different object, but you actually control the fields which were secure, crucial in that old object, but are no longer due to the placement of the object in the same place in memory. So that's use after 3. So that's like 2 different bugs basically. Yeah, and use after 3 is usually easier to exploit. Heap-based buffer overflows are more complicated to exploit. Is double freeing memory would double freeing memory cause memory corruptions? I guess that's the question. Anyway, yes, basically double free is exploitable. It usually requires some different bug to be around there. It's kind of used after 3, depending on what's exact the scenario, but it's kind of used after 3. But you are freeing an object and you are therefore deallocating the memory around it. And then if you allocate a larger object and or by some other means actually play with let me think about it, what I'm trying to say. Yeah, the idea is that if you deallocate the object, you basically change its meta information, which is usually somewhere near the object on the heap. And if you try to do it again, then the changed meta information should be treated as those of a live object, but the object is no longer live, it's free space. So that already might give you some way to corrupt the heap, and depending on how much control you have over other objects on the heap, you might actually try to massage, like write whatever condition out of that. It's a little more complicated. It was actually a long time it was believed that double free is not exploitable, as in you cannot get code execution of that, but then somebody came and proved that it's actually possible, but you do need a certain degree of control over heap to be able to do it. So it's basically boiled down to trying to interpret the meta information of a freed object as those of a live object, because these differ a little, they contain different things. It also boils down to the exact memory manager which we are talking about, but that's normal in heap bugs. But you have to basically know the implementation of that. And as you recall from my previous live streams, I'm not really well versed in heap stuff, so yeah. Okay, deleting C before D, it means the buffer doesn't get smaller. So the order of deletion doesn't matter too much depending on what you are going after, because you know, in memory it's basically like this. Let me just switch to this view. Sorry. So yeah, in memory it's probably going to be like this. You allocate one object which is going to be placed in memory here, you allocate the second one which is going to be placed here, you allocate the third one and the fourth one and so on. And if you allocate the, the smaller, favorite lists nodes, it's going to be placed in a different place in memory, because the memory manager, the modern memory managers try to separate the sizes of each. Well, maybe not each, but it has a bucket of sizes, and if the object is super small, then it uses this area of memory, but if it's a little larger, it uses this other area of memory, and if it's super large, it actually allocates the memory especially for it. So yeah, and then if we, it doesn't matter like the order if we deallocate this first or this second, except that if we deallocate this first, that is going to be placed in some cache. There's like a cache of freed memory locations for that place, and this thing is going to have the first position in that cache. So this cache is going to it's a linked list. It's pointing to this location, and then if we deallocate this, it's going to this is going to point to this, but this cache is no longer pointing here, it's going to point here. So this is a linked list, right? And if we start allocating, then we will probably allocate, depending on the implementation, but probably what will happen is the cache is going to grab this one, and it will return this area of memory again, and grab the pointer which was written here to actually make the cache point to this this area here again. And the second allocation would grab this one. So in our exploitation, that didn't really matter which one was which, because we had both on the favorite list. And initially, what I tried to do is I tried to be a little more surgical about it, a little more precise. And given that, yeah, and I tried to actually have a minimum amount of allocations and deallocations possible, and things on the favorite list as well. But in the end, it didn't matter. I don't know if it explained anything to you, but yeah. What does it mean, the double reference exploit versus the VF table exploit? What's a double reference exploit? Is it like when you have a pointer which points to a pointer? But it kind of sounds like that. So I'm not familiar with that term. If it's what I think it is that, yeah, you have basically, I don't know, like this, right? So, I didn't meant this to happen. Yeah. So you have, oh, that's interesting. Okay, yeah. So yeah, which basically means that you have something which points to a pointer, and this pointer points to something else, and depends on what you can override. If let's assume you can override this thing, right, with whatever your content is, then given how the code would normally use it, you'd maybe char star isn't the perfect example, but whatever. You would have to overwrite it with a memory location which contains a valid pointer to a different memory location. That might be it. Now, I'm not sure what you mean by the VF table exploit. Yeah, I don't know. Just catch me later on, so we can chat about it. I'm not really sure what you mean in that case. Okay, can I look at the page and see if it's worth looking? The VF table is rings a bell in my mind related to the file object function table. This is Garage for Hackers, a beginner's guide to use after free exploits, IE 6 2012. I know this person. I mean, yeah, try it. It looks to contain technical information. Okay, oh, it's just virtual table function for objects. Okay, so vtable. I don't know why it's called VF table. Maybe it's normally called just vtable. I mean, yeah, I'm not going to go through it now and read it, but yeah, try it. I mean, you know, when learning, you usually you usually read through hundreds of tutorials, books, and so on. So try it, I would say. There's com.folding for that. I'm not sure what com.folding actually is, in all honesty. I never heard that term. Oh, com.folding looks like merging of identical functions. Is that it? Thanks, KrzaQ, for the term. I'm going to actually look later on it. When you will be sending out postcards, I don't know. It's somewhere on my list of things to do, and quite high. So I probably should do it this month, hopefully. Okay, so that's it for the questions. So let's finish up here. Thank you for being here, and I hope at least something you understood something from what I'm trying to explain today. It was a little chaotic, I know, sorry about that. Next week is going to be playing with more programming tasks, basically with connecting two PCs with audio cables between sound cards, and I'm going to try to figure out if that is good for anything and if I can get any communication going one way or the other. I should, but let's see how it happens and how it goes. And thank you, KrzaQ, for being the moderator today, and again there's a mission today, so good luck and have fun. See you next week. And if you speak Polish, then see you tomorrow as well. Bye bye.
a hole